Hi everyone, I am Shubham Garg and welcome back to the lecture series of Tanner. So continuing the previous video, in today's video we are going to see how to create a shift register using the D flip-flop symbol. Okay, so we have created a D flip-flop schematic using NAND gates and inverter symbol. So now we are going to create a symbol for the D flip-flop and we are going to use that D flip-flop symbol to create a shift register. So first of all, let's see how to create that D flip-flop symbol. Alright, so here first of all let's remove all these power sources. And here, okay, we will be removing this Q bar as well because we only need that Q output. Alright, so here this is our D flip-flop now, and now we are going to save this. So now what we are going to do is we are going to go to cell, click on generate symbols, make sure the library is D flip-flop or your specific library, and just click on replace. Alright, save this, go to cell, new view, and in the D flip-flop library create a cell that is, let's say DFF Symbol, and cell type as schematic. So click OK, and here in the D flip-flop you will see this DFF symbol. First of all, save this, and here is your DFF symbol. You can just create an instance, and here you have your D flip-flop. Alright, so now we are going to create a new library for the shift register. So I am going to go to file and clicking on new library. So here I am going to create a new folder that is for shift register, and I am going to name my library as shift register. So here I have created a new library, and in the new library I am going to create a new view. First of all, let's save this as well. So here I have a new view, and I am going to have a new view in the library shift register. So the cell name will be shift register. Okay. So I am clicking OK, and here okay, I am going to go to D flip-flop, and I am taking this symbol and I am going to have it as an instance. Alright, so I will be having the 4 D flip-flops. Okay, I will just show the schematic diagram. Okay, in just a minute, so you will understand why I am taking 4 D flip-flops. Okay, so here this is the diagram for a shift register using D flip-flop. So you can see there are 4 D flip-flops. Okay, it is data in is connected here, and the output is connected to the input of the next D flip-flop. Similarly, its output is connected to the next, and this is connected to the next, which is finally connected to the Q4. Alright, so we will be having, these are the intermediate bits, that is first, second, third bit, Q, because it is a 4-bit shift register. So these are Q1, Q2, Q3 and Q4, and finally we have this clock with a single clock connected to all of these. Alright, so this is how we are going to make our schematic. So here when we zoom it, we can see, okay, the above one is the clock. Okay, that's how the symbol got generated. Above one is the clock and the lower one is the data. So let me just move the positions, their positions a bit, so that it will become easier to connect. Yeah, so that you see output is at the same node as the data, so it will be easier to connect. Similarly, this output needs to be at the same node as data. Okay, and similarly this output should be same as that of data. Yeah, so it will be basically becoming a ladder like structure. Yeah, but that's okay, no problem. So it will make it easier to connect. Alright, so here now we are going to connect the wires, that is the output of this to the input of the other D flip-flop, output of this to the input of other, output of this to the input of other, and this is finally the output. Here we are going to connect the output. Okay, you can also connect the outputs at the intermediate ports as well, that won't do any harm. Okay, so let's connect, it's okay, and we will just connect the probe on the output only, on the Q4 only. Okay, so here this one is the Q3. Similarly, this one is Q2, and this one is Q1. All right, so we have connected the output ports. Now what we need to do is we need to connect the clock. Okay, so we need to have the common clock. So first of all, let's make a common wire. Yeah, and we can connect it like this. Okay, so now we can connect the clock terminal like this, similarly like this, and finally like this. And here we will be providing the input like this, and we are going to name it as CLK, that is for clock. Let's extend this. Yeah, and now connect this. So and there is our data in. So for the inputs, let's go to Spice sources and select VBit. Just create an instance, and here is our VBit, that is for the clock input, and this VBit is for data input. Okay, so here again another input port. So this is our input port, and this will be data. Okay, so now what we need, what we are left with is VDD and ground. So go to miscellaneous and select ground. So just create an instance and paste the ground like this. Okay, just zoom in, see the left one is ground, this is the ground, this is a ground, and this is a ground. Alright, so we have connected all the grounds. Similarly, we will be connecting the VDD. So create an instance. So here is our VDDs. And finally, what we are left with is the VDC source. Okay, so this is how our connections are made for shift register. And now we have the VDC source. Let's go to Spice sources, create an instance. Here is our VDC source. Just copy the ground and copy the VDD. Yeah, so now it is fine, it looks fine. Okay, so this is how our circuit looks like. Now let us try and run the program. Okay, before that, let's use a plot. I forgot it once again. Yeah, so voltage print. Our plot. Okay, just a second, my system is hanging. Yeah, now it is fine. So here it is for voltage print. Let's take this as an instance, and for this data here, I'm going to paste it here, and finally another voltage print at the output. Okay, so this is our voltage print for the input and output. We can add the voltage print at the intermediates as well, that's okay. So let's do one thing, let's add, we will see. So this is print voltage here, print voltage here, and print voltage here. Alright, so this is how our 4-bit shift register looks like. And one more thing, there, just change the pattern for the clock to be 1111 so that our clock is enabled all the time. Okay, so now we are done with everything. Let's just start the simulation. We'll be doing transient analysis, and there is our library file. Let's hope our circuit works fine. Okay. Okay, there are some plots. Let's see. Okay, so we can see here when we zoom into the plots, we can see there is some shift, that is shift in a cycle of these inputs. We can see here that let's say in this 40 to 41, this 1 nanosecond step time, that is when the input is supplied. Here the finally the output, that is Q1, Q2, Q3 and Q4, the final output, there is a shift, that is from 48 shifted towards the 41. That is bit by bit the data is shifting. All right, that is every data you can see in every cycle, it is shifting bit by bit. Okay, so this is how our shift register works, that is we have the shifts in our data. Okay, here also we can see the input is provided at 10, the output basically shifted towards the 11. So this is how shift register works, and we are finally getting the shifts. So this is how we can use the symbols to create the complex circuits. And you see, this is how you can organize your libraries here, so that you will be able to easily identify your design. You can easily able to modify your design, work with your design. Okay, and you can use your design and symbols in any other designs. See, for example, I need to use NAND symbol, I have it right here. If I have to use D flip-flop, I have it right here. So this is how these things are done. So this is all for this video. See you guys in the next video.